This demonstration presents the Trustee Explainable AI tool, which is part of the AI model as a service component. It showcases how a model consumer can utilize the platform's explainable AI capabilities in combination with global models generated through Trustee's federated learning process and a locally stored dataset to produce clear and interpretable explanations of model decisions. In this demonstration, a model from the healthcare domain is used for condition prediction, which we assume has been created through Trustee's FL process. Using patients' vital health indicators, such as heart rate, blood pressure, temperature, and respiratory rate, the model explores predictions of Glasgow Coma Scale score. The demonstration begins on the home page of the XAI dashboard, which provides an overview of the platform and its main features. From here, we navigate to the Tabular Explainer tab, which is the primary focus of this demonstration. The dashboard is divided into two main sections, a left sidebar and a main workspace on the right. The left sidebar is used for configuration, while the main workspace contains multiple tabs, each offering different functionalities. The first step is to upload a local dataset using the File Explorer. Once the data is successfully loaded, key information about the dataset is displayed. Next, we select a machine learning model from the data lake. When the model is loaded, its metadata appears on the screen. Alternatively, the dashboard also allows users to upload a locally stored model. After completing the configuration, we focus on the main workspace, where the available functionalities are organized into tabs. We begin with the Data tab. This section enables data exploration by presenting information about each feature and its values, along with descriptive statistics such as unique values, mean, and standard deviation. Next, we move to the Visualizations tab. Here, users can explore relationships within the dataset using interactive scatter plots. By selecting two features, we can analyze their correlation. For example, this plot shows the relationship between heart rate and blood pressure. We then proceed to the Predictions tab, where we generate and examine model predictions. This page begins with detailed usage instructions. Below, the Model Info section displays important information such as the model type, task, and characteristics. To generate predictions, we first select the input features and records. By default, all available features and records are selected, but users may also choose specific subsets. Once the selections are complete, we click the Generate button to produce predictions. In the Output section, the input data appears on the left, while the corresponding predictions for each record are shown on the right. Next, we navigate to the Explanations tab, where both global and local explanations are generated. This page also includes detailed usage instructions. In the explainability options, we select the desired method. By default, the SHAP method is used. As in the Predictions tab, we select the features and records and then generate the explanations. The results are presented in two sections, global and local explanations. Global explanations show overall feature importance. These are displayed both as numerical values and as a bar chart for easier comparison. A textual summary highlights the three most influential features. The dashboard also supports AI-generated explanations, which provide more human-readable insights into how features influence predictions. This functionality requires access to an external API and is not included in this demonstration. For local explanations, we select an individual record from the dataset. The left panel displays the feature values and their importance scores, while the right panel visualizes these contributions using bar charts. A textual explanation summarizes the three most important features for the selected record. Next, we move to the What If tab. This section allows users to explore how changes in input values affect model predictions. Usage instructions are provided at the top of the page. We select the features to include in the analysis, or keep the default option of using all available features. Then we choose a base record, in this case, record number 4. We modify selected values, such as temperature, heart rate, and respiratory rate, and generate a new prediction. The updated result shows how these changes influence the model's output. Finally, we navigate to the Reporting tab. This section consolidates information about the dataset, the model, and the generated explanations into a comprehensive report. Here, we can view details such as the dataset name, number of samples, and feature list. Model-related information includes the model ID, size, name, and input and output specifications. The report also contains details about the explainability process, including the method used and the global feature importance scores. Users can choose which elements to include in the final report. First, we submit the explainability report to the Trustee Knowledge repository. After submission, a success message is displayed. We also demonstrate how this transaction is recorded in the Accountable Transactions Recorder. In addition, the report can be downloaded locally as a JSON file. This concludes the demonstration of the Trustee Explainable AI tool.